Now let's see the next property, that is associative property. Can anyone tell me why we are studying these properties? Like one by one, we will study many properties: associative property, closure property, identity property, all these properties. Why we study them? Because I told you that these properties will decide to group things, many different structures. They have the same property, they have the common property. Okay, so that is the reason we study these properties. These properties are important so that we can group many different things together from many different fields, from physics, chemistry, cryptography. Okay, different things can have same properties, and if two things have same properties, then we can study them together. Okay, so that's the idea. So anyway, let's see the next property, that is associative property. What is the definition of associative property? This is very simple. If you have some operation, let's assume you have this set, so this is your set and this is some operation. This is associative. When can I say that this is associative? Means this will satisfy associative property. When can I say that this is associative? If and only if whatever three elements you take, same or different, whatever three. So whatever three elements you take, if you have this type of thing, then you can notice that whether you do this first hash first or whether you do this second hash first, the result must always be same. This is the definition of associative. What it means, this hash you can associate basically. Okay, this hash you can do this first hash first or you can do this second hash first, the result must be same. This is the definition of associative property. Means whatever three elements you take, for any three elements, for any three elements, this should happen. Okay, A hash, B hash, C, whether you do this first hash or you do this second hash first, they must always be same. Then this is called associative property. Now tell me, can I say set of natural number is associative under addition? Set of natural number, can I say this is associative under addition? This will satisfy associative property, right? Yes, this is associative, because we already know that if you take any three, A plus B plus C, now we already know that A plus B plus C, whether you do this first addition first or whether you do this second addition first, answer will be same for all ABC, whatever three you take. For example, if you take 2, 2, 3, 2, 2, 3, if you take 2, 2, 3, now you can notice this and this, they are actually same. So this is the definition of associative property. So set of natural numbers are associative under addition operation. What about rational number under multiplication? What about that? Yes, multiplication is associative, because if you do A multiplied by B multiplied by C, this is same as this, both are same. Whether you do this or whether you do this, both will be same. So multiplication is associative. Let me tell you, this addition, multiplication, these are always associative. These are addition, multiplication, these are always associative. Whatever base set you take, these are always associative. It does not matter which base set you take. Okay, on all base set, on whatever base set you take. What about set of real number comma division? Set of real number comma division, is it closed? This is my question, is this closed? So the answer is no. The answer is no, because what is the result of 0 by 0? For example, if you take A equal to 0, if you take B equal to 0, then what is the result of A divided by 0? Means this 0 by 0. What is this result? Okay, so because this result is undefined, I can say this result, if you notice, this result is undefined. This result is undefined. So I can say this is not closed. Let me take this example. On set of natural number, I am defining a new operation. And this new operation is like this. See, new operation I am defining. And this new operation is like this. A hash B, this is equal to A square plus B. Is it closed? First you tell me. Is this closed? My first question, is it closed? First you understand this actually. Okay. So this new operation is defined. A square B plus. First you understand the operation. Always, this is the first thing. Understand the operation. This is the first thing you should do. Understand the operation. So tell me, what is 2 hash 2? What is that? So remember, a hash b means a square plus b. So this will be 2 square plus 2. This will be 6. What is 1 hash 2? That will be 1 square plus 2. That will be 3. What is 2 hash 1? That will be 2 square plus 1. And that will be 5. So first you understand the operation. Okay, clearly understand the operation. Now tell me, is it closed? So this operation on set of natural number, this new operation I have defined, is this closed? Yes, this is closed, because if you take any two natural number, if you take a comma b, which are natural number, then a square is a natural, right? Agree? So a square is also natural number. A square is also natural number. And if a square is natural number, then a square plus b is also natural number. So I can say this is closed. What about associative property? Let's check associative property. Remember, for associative property, what you have to do? This is what you have to do. This should happen. If you want to check associative property, then this should happen. Associative property means this and this. They should be exactly equal for all a comma b comma c. This should happen. Now let's check them. So can I say, are they same? A hash b hash c. Can I say this and this? Let's check whether they are same or not. Okay, let's check. What this will become? This will become a square plus b hash c. Correct? Because this is a square plus b. Now, what should I write? Can anyone tell me? This hash this. What that will be? This has this. That will be this square plus c. So that will be this square plus c. So actually it will be a power 4 plus b square plus 2a square b plus c. And now you can clearly see this is not same as this, because what is this? This is a hash b square plus c. And what this will become? This will become a square plus b square plus c. Clearly they are not same. They are not same. So I can say that this is not associative. So not associative. So associative property is not satisfied. So for associative property, this is what you need to check.